mechanics, it has got three parts. What are those? Statics, then kinematics, and then dynamics. What is statics? It is a branch of mechanics where we study the objects at rest, right? So in statics, there is no time factor. So here, time factor does not play any role here. Now, kinematics. It describes the of objects, motion of objects without looking the cause of motion, without looking the cause of motion. The moving body that goes on moving, undergoes some motion. It doesn't not know. It doesn't know that is why it is moving, which is responsible for its movement. It means there is no cause involved for this motion. So it's a natural phenomenon, right? So here the time factor is there. Time factor is there. But in the case of dynamics, it relates the motion of the object. It relates the motion of the object to the force, which caused them. And that's why we call it dynamics. So time factor also takes place here in a very important role. So this is about the mechanics. This is the general introduction about the mechanics. So before discussing the straight line, that is motion in straight line, we should be aware of certain basic aspects. Now let me explain about the frame of reference. Take down. Frame of reference. Let us choose a rectangular coordinate system. It means we have got x-axis, y-axis, and z-axis. Okay. So here the origin is said O here. It is represented as O. So that is why this origin is supposed to be the reference point. Origin is the reference point. Suppose this is x, this is y, this is z, means along x-axis there will be some movement, along y-axis there will be some movement, along z-axis there will be some movement. So this is represented as though it has been originated from the origin, that is O, and that is why it's called a reference point. And all these xy are based on this reference point only. So this is the coordinate system, right? Now to measure a time you need a clock, right? So the coordinate system along with the clock constitute the frame of reference. Okay, together it should be frame of reference. So the frame of reference is a coordinate system with a clock with respect to which an observer can describe the position, displacement, acceleration of an object. For example, one guy may be looking from here, another may be looking from here, another may be looking from here. So it means these are all with respect to the time and the position we are deciding. So together they are called the frame of reference. So do you understand this basic concept? So the frame of reference can be of two types. One is called initial frame reference. Initial frame reference. Second, non-initial. Non-initial frame of reference. So here Newton's law of motion is applicable. Whereas for non, actually this is not initial, I must say inertial. Please correct it. Inertial. And this is non-inertial. So inertial and non-inertial. Inertia means the tendency to undergo any change, non-reactiveness, you can say simply. So inertia here. So inertial frame of reference and non-inertial frame of reference where Newton's law is not applicable. Okay. Now let us consider the point object. Point object, also known as point mass. Take down point mass. See, the object is considered as point, that is, as point object. When the size of the object is very much smaller than the distance it moves reasonably duration of that during the time, during some reasonable duration of the time. For example, a train under journey of several hundred kilometers can be regarded as point object. Let us not worry about the length of the train, but it is traveling like this. So when you compare these distances, this train object is almost considered as a point mass. I hope now you should be able to understand this. Prisha, do you understand?
Yes, sir. So basically, like the size of the object compared to the distance that it has traveled.
Yes.
If the distance is more than the size, then it is point objective point more.
So this is the point mass. And so in this case, a train can be considered because it undergoes several kilometers, hundreds of kilometers. So the length of the train as a whole can be considered as a point mass. And similarly, an earth can be regarded as a point mass, that is point object for studying its motion around the sun. Okay. So compared to the distance it is traveling, we can consider earth as a mass, that is point mass, that is object, point object. Okay. So this you must have some idea. Then what about this rest? We'll try to define this rest. Rest is nothing but, see, the position of an object does not change. with respect to its surrounding with the passage of time, then it is called the rests. So what do you mean by rest? It is the position of the object, position of the object does not change, does not change with respect to its passage of time. Then you can say it is rest. For example, this mouse is at rest, but it is based on the time. After some time, I may keep this aside. Now it has displaced. Okay. So it means these are all based on the time factor only. Similarly, a person sitting on a chair or book lying on a table, apparently they are rest, but the time alone decides the position. Now let us consider the motion. When the position of an object is continuously changing with its surrounding, then it is said to be in the state of motion. This motion can be divided into three types. It is based on the nature of the path it follows. So, types of motion. The rectilinear motion, circular motion, oscillatory motion. What are the three kinds of motions? Rectilinear. What do you mean by rectilinear? It moves in straight line. That is a motion of a sliding body on an inclined plane. For example, you have got some incline. So here the body can be sliding. So linear motion. Circular motion means it adopts a circular motion and completes a 360-degree. Then oscillatory motion means it's a kind of periodical motion like a simple pendulum. It goes to the maximum point on the right and comes across the neutral point, then go to the other extreme and comes back. So this kind of motion is called oscillation, that is oscillatory motion. Example, simple pendulum. Now, on the basis of the number of coordinates required to define the motion can be called a one-dimensional motion, two-dimensional motion, then three-dimensional motion. So, one-dimensional motion, two-dimensional motion, three-dimensional motion. In the case of one-dimensional motion, probably it goes only in the x-axis. In the case of a two-dimensional motion, you have got the x-axis and this is the y-axis. Okay, so here it can move anywhere, but within this plane only. So this is called a two-dimensional motion. Three-dimensional motion means that is it has got greater liberty. Okay, so it means that is when you take that is this as x-axis, y-axis, and this is z-axis. As I already discussed, there is a fly. It is traveling here around the space in all dimensions. That is three-dimensional motion, like a butterfly flying in garden, no? Right. Now, let me ask you one simple question. In your room, you've got a wall like this. Okay, so it can be a rectangular, that is a cuboidal shape. Is it not? Your room. Let me consider like this. Okay. And let me take this as x-axis. This is y-axis. This is z-axis. Right. So here, this is the floor. What is this plane? XY plane.
Yes, yes.
XY plane. Okay. You can also draw. And where is your ceiling fan rotating?
In the
From the
bed,
from the top.
right above that view.
Yeah. So what is this plane?
That by it's by Z.
That is also XY plane only. Okay. That is also XY plane only, but it is shifted in the Z direction. You got this point? Okay. It is shifted in the Z direction, but the plane is only this. Okay. And now that is on the right side. Some lizard is climbing on the wall. Okay. So what is that plane?
Z by Z.
This is Z and this is X. So X is that plane, right?
Oh,
But it is shifted in the Y direction. Do you understand?
yes.
Okay. So likewise, you should have some perspective view also and some you have to visualize such kind of motions also. Okay. Right. Now let me move to the next aspect, that is now you know about the quantities and that are they are classified into two, scalar and vector.
Vector.
So in scalar you have magnitude and no direction, whereas in vector here you have magnitude and direction. Okay. For example, mass is a scalar quantity, then length, that is also scalar quantity, time, scalar quantity, speed, scalar quantity. But what about displacement? Displacement is a vector, right? Then velocity is also a vector. Then acceleration is also a vector. Now you have got the speed and velocity. So what is the velocity? Speed? Distance divided by time, right? And what about the velocity? Displacement divided by time. So you should know the difference between these two, right? Prisha, you can mute.
Yes.
Then now let us move on to some of the important definitions relating to the motion. Important terms associated with the motion. Let me discuss once again. Position. 2. Path length. Path length. That is distance. Now let me try defining the position. That is, it is defined as the point where an object is situated. For example, let me draw a line x-axis, and this is the origin. So from the origin, that is, you've got 1, 2, 3 on the positive direction, and this is the negative direction. So here we have 1, -1, -2, -3, right? And this is +1, +2, etc. Okay. So the position can be determined by the coordinate axis that is marked in the unit of length, and that has positive direction and negative direction. For example, an object is situated at -1. The position is -1. Here the object is positioned at -1. Okay. So it indicates that the position of the negative direction, position in the negative direction. Are you able to follow? And let me consider this position. So let me say this is S1, this is S2. What is the position of S1? -1 with respect to 0. What is the position of S2? 2 with respect to 0. I hope now you should be able to understand the reference point here, right? Then path length. Path length is also called the distance. That is the distance traveled. And what is the SI unit? Meter, right? Let us discuss one problem. A scooter is moving, take down. A scooter is moving along a straight line. AB covers the distance 360 meter in 24 seconds. And travels from B to C 240 meter in 18 seconds. The C is positioned between A and B. Find the distance traveled. Find the distance traveled. That is path length traveled by the scooter. Now let us visualize this with a neat diagram. So he has started from A, starting point, and he has gone to 360 meter. That is point B. Then he comes back to C because C is in between A and B. So in the same straight line, he has come here, that is C, right? So what is the distance of A and B? The distance of A and B is how much?
360.
360 meter. And what is the distance between B and C?
240.
That is 240 meter, right? Now, what is the total length? That is the total distance traveled by the scooter. It means AB plus BC, right? So what is AB here? 360, and this is 240. BC is 240. So you can say 600 meter. This is the total distance traveled. Okay, right. Now let us discuss about the displacement.
So I have one question.
Yeah.
So if a train is running in the straight line, it's one dimension motion.
Hmm.
But the moment it takes a turn, this is two dimension motion.
Now we take this as a one dimension. What is that? What's the doubt?
If it takes a turn, like it moves left or right.
No, 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 he is not taking any turn. So we are just, that is why I asked you to consider this as a point mass. Do you understand this?
Okay.
So where is the question of a turning, U-turn, reverse turn for a point? All turns are one for them. Okay. So you can consider this as a point object. Okay. You should not take it as a reality, right? So, as far as this motion is concerned, we had to consider like this. The scooter wala goes here from A to B and turns at the same point, then comes back to C. So, likewise, we have to take. Okay. You need not consider the turning point, what is arc length, all these things, right? Okay. Then, displacement, take down. The change in position of an object, the change in position of an object is called displacement. So it is the difference between the final and the initial position of the object. We can represent this as a delta x. Assuming that x2 is the final position and x1 is the initial position, so the difference is displacement. There are three cases here. Case 1, if x2 is greater than x1, the displacement is positive, that is greater than 0. Okay, delta x is greater than 0. Suppose if x1 is greater than x2, then delta x is negative, right? That is, the displacement is negative. And the third case is when x1 is equal to x2, it means there is a zero displacement, that is delta x is 0. Do you understand? So actually displacement is a vector quantity. Displacement is a vector quantity. It possesses both magnitude and direction. Let us consider an example that illustrates the displacement and the distance, the difference between the distance and displacement. Take down. A boy starts from minus 20 meter. Let me draw a x-axis. Let us consider O is the origin. And a boy starts from moving from minus 20 meter. Let me consider this as minus 20 meter. He starts moving from here towards the positive axis. So towards the positive axis. He turns at time instant t2. So at the t2 and starts moving towards minus axis. So he is returning in the minus axis like this. So this is a forward motion. Now he is returning. At time T3, he reached 50 meter. So he has reached minus 50 meter here. Minus 50 meter. This is the T3 position. He reached minus 50 meter at T3. So this is shown in the diagram. Now let us analyze the distance traveled here. And this is 20 means this one will be plus 20. Is it not? So plus 50 like that it goes. Now, and where from he started? He started from minus 20. So let us take this as T1 instant. Okay. So for T1 to T2, for T1 to T2, what is the distance covered? The distance covered is, and it is indicated when he reaches T2, it is plus 40. So here it is plus 40. Okay. Right. From T1 to T2, the distance covered is equal to, that is this 20, is it not? Plus this 40, right? So it means when I put this as OA and this is O, this is B means OA plus OB, right? You have to straight away add. What is the distance traveled here? 20 plus what is the distance traveled here? 40. So totally 60. How much meter, right? So this is the distance traveled. So the distance traveled is 60 meter. But when you consider the displacement, remember displacement. So here the T2 minus T1, is it not? T2 minus T1 position. That is the displacement at the T2, the position at the T2 minus the position at the T1. So you can put like this. Position at the T2 minus position at the T1. So what is the position at the T2? The position at the T2 is 40, right? Minus what is the position at the T1? That is minus 20. Okay. So automatically that is it becomes 40 plus 20, we call it 60 meter. This is towards x-axis. Now listen to me very carefully. I am talking about T1 to T2. Now let us work out for T1 to T3. Okay. T1 to T3. For T1 to T3. Now the distance covered. So the distance covered is, look at the graph here. It is, see that this is T1. Listen to me carefully. This is T1. And where is T3? The T3 is this much. So what is the distance he has already traveled from T1 to T2 and comes back? that is 60. So you have to consider that 60, right? And then now again is traveling. Okay. So again he is traveling means that is he is traveling about say 90 meter distance totally covered here because this is one distance and this 50 meter to 40 meter another distance. So you have to say 90 meter. So the total distance is 150 meter. But when you calculate the displacement, when you calculate the displacement, now the displacement is, it is here T1, is it not? And this is T3. So what is the position of T3? That is minus 50 meter. So what is our formula? T3 minus T1. That is position at T3. Position. Yes means position. Position at T1. Or you can put X also. X at T3 minus X at T1. So what is the position at T3? Tell me. Here. 50. Minus 50. So you have to consider this minus 50. Minus. And what is the position at X1? I mean T1? Minus 20. So minus 20. Therefore, minus 50 minus or minus plus. So you must say 30 meter displacement. Okay. It means it is a negative to the x-axis. That is negative x-axis. I hope now you should be able to understand the difference between the what? The distance and displacement. If there is. Hmm. This is because we have to consider only the distance from the original point. For example, 60 meter, how you are, I mean, this one, say that is a T1 to T2. So T1 to T2. So from here to here, there is already 20, right? And from O to 40, that is 40. So totally 60, right? So this distance is 60. And what about this distance? This is from 50 to 0, 50, minus 50 to 0, 50, and 0 to 40, 40. So what is the total distance? For 50 minus, plus 40. So here we don't take any negative values. So 50 plus 40 means 90. Now, what is the distance here? That is 60, which is from here, 90 from here. So total distance traveled means 150 meter. Okay.
Okay.
Now let me give you some simple example. Now you have come to Chennai to Saitech Institute. So we are here at Saitech. Now your Lord hotel is here. Okay, hotel is here. Now you have got some. You have booked some auto. Okay, so you are coming to Saitech. Okay, and goes back to what? Hotel. Clear? So the distance for this is say about 40 kilometer, and this is also 40 kilometer, right? So what is your displacement? You have come this side plus 40 minus 40, so net is 0. But can you claim that? Can you demand or can you fight with the auto driver that I have undergone only 0 displacement, so I cannot give you money? Will you accept? I hope now you should be able to understand the difference between the distance and the displacement. Clear? So in the case of displacement, direction is involved, but in the case of distance, the direction is not at all included. I hope now you should be able to understand this. So this is the way I can explain once again. For example, from 0, the T3 is 50 meter. So that should be taken into account. And from this 0, that T2 is another 40 meter. Got it? So for him, 50 plus 40, and then that is you have got this 20 also. Okay, so what is the distance between this? 60. So 50 plus 40 plus 60. So totally 150. I hope now you should be able to understand. Okay, then average speed picked up. Average speed is represented by VAV, we can put average speed. This is given by the total distance traveled. Okay, total distance traveled divided by the total time taken. Okay, let us consider two cases, case 1 and case 2. A particle covers the distance S1, S2, S3, and so on up to Sn with the speed V1, V2, V3, etc. up to Vn, right? Okay. Now, what is the average velocity? Average velocity is S1 plus S2 plus S3, etc. up to Sn whole divided by, okay. So this is the average speed, is it not? And what is the time taken? Can you tell me? T1, T2, but I have given only as V1. So how you can relate? We know S is equal to Vt, right? And what is T? T is equal to S by V. So if we want to find out T1, which is nothing but S1 V1 divided by V1. Got it? What is T2? S2 by V2. So actually you are supposed to add T1 plus T2 plus 3, etc. up to Tn. But we don't have the time factor here. Say what I can do? I can substitute this time factor by Sn divided by V1 and so. Therefore, V average is equal to Sn1 plus Sn2 plus etc. up to Sn whole divided by S1 divided by V1 plus S2 divided by V2 plus and so on up to Sn divided by Vn. So do you understand this?
Yes.
So in case time is not given, you can make use of this equation like this. Okay. Now case 2. If a particle moves with the speeds of V1, V2, V3 and the time factor is given T1, T2, T3. So in that case, how the average speed can be calculated. So we will work out. Okay. So case 2. So here what I am doing, I have got the various velocity V1, V2, V3, etc. So these are all known. And the time intervals are also given. So T1, T2, T3, etc. up to Tn. But the problem here is which is not given. The displacement is not given, right?
Yes.
Yeah. So what we are supposed to do? We know the formula S is equal to Vt, right? Okay. So we can make use of this S1 is equal to V1 T1. Okay. S2 is equal to V2 T2, right? Now we can substitute. And what is the general equation? What is that? Average speed means what?
Uh,
Total
it's
total distance traveled divided by total time, right? Okay. So it means V average is equal to total distance, that is S1 plus S2 plus S3 and so on plus Sn whole divided by T1 plus T2 plus T3 and so on plus Tn, right? Now we don't have this S1, so we can put V1. Therefore, V average is equal to, what is that? Instead of S1, we can put V1 T1 plus V2 T2 plus and so on plus Vn Tn whole divided by T1 plus T2 plus T3 etc. Tn. Okay, do you understand this concept? Right? And these summations can be easily represented, like for example, when you want to make Sn1 plus Sn2 etc. up to Sn, you can simply put the summation of I that starts from 1 I to n. I starts from 1. So it means you can put I, that's all. So this is a simple way to represent the total distance, right? How you can mention the time like this? So I is equal to 1. So I can put Ti up to n, right? Similarly, that is velocity also can be represented. So V, so summation Vi and I is equal to 1 up to n. So this is a way you can represent. So in that case, how you can represent the average velocity? The average velocity or average speed here is represented as summation of the distance. Is it not? So Si. So I is equal to 1 up to n whole divided by summation of I is equal to 1 up to n for Ti, right? Are you able to understand this kind of representation? Right. Now let us discuss some problems based on this average speed, right? Take down. Your car covers, next problem. Your car covers the first half of the distance. Your car covers the first half of the distance between two places. Two places at a speed of 40 kilometer per hour. So this is the speed at first half. And the second half, it picks up 60 kilometer per hour. This is the second half. Calculate the average speed of the car. So how you can proceed? A car moves with the speed, let me say first half, the first half speed, that is V1 is equal to how much? 40 kilometer per hour. Got it? And the second half, V2, 60 kilometer per hour, right? 60 kilometer per hour. Now, what is the total distance traveled? We do not know because they simply said distance between the two places. That's all, but they are not mentioned. Okay, so let us call it X. So the total distance traveled by the car is X kilometer. Okay, and what could be the first half distance? That is exact because it is said half. For example, let me consider the car is moving like this, starting from A up to B. So first half means the total distance is x, and the first half means x by 2. The second half is also x by 2. Do you understand this? Okay. So here the total distance is equal to x kilometer. So the distance of the distance of first half, first half, let us say S1 is equal to the distance covered in the first half is equal to x by 2. And the distance covered in the second half, that is S2, is equal to again s by 2, right? Why? Because it is said the half of that distance. Okay. Now, what is the time taken? This is T1, this is T2, right? Okay. Now, let us consider the total time taken. Okay. Take down the total time taken. T is equal to T1 plus T2, right? And we know already S is equal to what is the formula? Vt. And what is the T? T is nothing but what is that? S by V, right? Okay.
Yes, sir.
So let me say S1 in that case V1 T1, S2 here V2 T2. So from this we can calculate T1, that is S1 by V1, right? T2 S2 by V2. Okay, got it? Now S1, listen to me carefully. S1 is equal to S2. Do you know why? Because it is said that half the distance, right? So both of them are equal to x by 2. Got it? And what about the V1 and V2? V1 is how much? 40 kilometer. Am I right? Okay.
Yes, sir.
And what about V2?
60 kilometers.
60 kilometer. Now we can calculate what is the T1, ma? S1 by V1. Okay, what is S1 here? X by 2 divided by how much?
X by 2 divided by 40.
Very good. So 40, it means X by 80 hours, right?
Yes, sir.
Right. And similarly, what is T2? X by 2 divided by 60. Now what is T2?
6 by 120.
Very good. So this is X by 120 hour. Okay. Got it?
Yes, sir.
Now average speed is equal to what is the formula? Tell me.
Total distance.
S1,
And
S1 plus S2 divided by T1 plus T2, right? So this is the formula. Now you can substitute. No? So what is S1? Tell me. X by 2 here. Okay. And what is S2? That is also X by 2, right? Whole divided by. What is T1?
X by 80.
X by 80. What is T2?
X by 1.
X by 120. Now you can take LCM, take it. So X by 2 plus X by 2, how much? Okay. X. So X by 2 plus X by 2 means 2 LCM, and this is X plus X. So 2x by 2 cancel. So X. Okay. And what is the total of this one? X by 80 plus x by 80, 20, 120. 80 plus x by 120. Now take LCM,
240.
240. So this is 3 times 3x. And what about this? 2 times 2x. So 5x by 40. Now you got the formula V average. V average is equal to this x by 2 plus x by 2. What is the value? X divided by x by 80 plus x by 120 means that is this one. So 5x by 40, 240. So 5x by 240. So x by 5x into 240, right? X cancel and 5 4 times and 8 times. So 48 kilometer per hour. This is the average speed. Okay.
Yes, sir.
So see, without knowing the distance, we are able to calculate the average speed. So that is the beauty of physics here, right? Are you able to understand?
Yes, sir.
Right. So see, what you are supposed to do is you have to immediately go through whatever I am discussing in the class. Okay. So and try to do these problems. First, you can understand very well, then go through that and work out once again and try to work out without referring to that. So it should come smoothly. And suppose if it is a 3 marks question, you are supposed to finish it in 6 minutes. So you have to maintain that speed, right? Now let me move to the average velocity. Okay, take down average velocity. And let us draw a plot. Y-axis, x-axis, origin. Draw this plot. And this is called the position time graph for displacement. What is that? Position time graph for displacement. Let me say that is the x-axis is time. Y-axis, that is the position. Let us indicate the time as here. Let me consider 2 times here, t1, t2. At that time, the position of an object is at x1. Okay. So this is the position P. And at position T2, it has gone to R. So this position is x2 and this time is t2. So the straight path is PR, but the body moves a curved path like this, that is 70. And you can draw, yes, you can extend this x1p here and let it meet at Q. So the distance between R and Q, that is delta y, right? In this case, I have taken this as x, so you can put delta x. And the distance between the P and R in time axis. So this is what? Delta t, right? So what is the displacement of the body? The displacement of the body is delta x, x2 minus x1. The total time taken for the displacement, okay, delta t, t2 minus t1. So for delta x, it is a displacement x2 minus x1. What is this? Delta t.
So,
Yes,
why are we taking delta t and not the total time?
it is not total. This is displacement means it you have to subtract final minus initial. Whenever you consider the velocity, you have to consider only final point, initial point. That's all, right? So that is why I taken x2 minus x1. And here the time change, that is t2 minus t1, right? So in that case, average velocity is equal to delta x divided by delta t. So this is the formula. Now listen to me. When I define the average speed, I would have used the term the total, but here I am taking the net change in the velocity. Okay, do you understand this? You look at this. Average speed means I have used the term total displaced distance traveled divided by total. So that is why I am totaling everything, right? Okay.
Yes, sir.
But when I discuss about the average velocity, I am not using the term total. Instead, I am using net, means the difference, right? Final minus initial.
Yes.
So delta x divided by delta t, right? So in that case, this delta x divided by delta t that indicates the slope of the line. Delta x divided by delta t is nothing but the slope of line. So what is the slope of line, which is nothing but what is this delta x divided by delta t? Delta x means PQ, RQ divided by QP, QP or PQ. Okay. So here you have to mention this as average velocity is equal to what is that? That is x2 minus x1 divided by t2 minus t1, which is nothing but PQ. Is it not? RQ, sorry, RQ divided by this QP, which is nothing but the slope of the curve. Okay, slope of line here. Okay,
Yes, sir.
now let us discuss a problem based on this. Right now, your car is moving along a straight line. say OP. This is O, this is P. In between, you have Q, and here you have R, and O is the origin. So here it increases plus minus. So minus x plus x. And Q is at 240. The position of P is at 360. The position of R is a minus 120. Okay, right. So a car is moving along a straight line, say OP. So from here to here it's traveling. It moves from O to P in 18 seconds. So OP. So time taken for OP. How much? 18 seconds. And returns to P. Returns from P to Q. So P to Q. So P to Q. In 6 seconds. 6 seconds. Whatever the average velocity and average speed. Average velocity and average speed. So I'm using capital V for average speed, small v for average velocity. So both are asked. In going from O to P, second question, from O to P and back to Q. This is the question. Let us try to understand the question first of all. So they are given all these distances, and they are given the time also. Now what they have asked, what is the average speed, average velocity in two cases from O to P, from O to P. In the next case from O to P, and then comes back to P to Q. Okay. Now we have to do the calculation carefully. Solution. Now let us consider the car traveling from O to P, right? O to P means 0 to 360. Okay. So what is the average velocity that is given by the total, the net displacement divided by time interval. Okay. So it means 360. Okay. You can put x2 minus x1. This is x1, this is x2. So x2 minus x1 divided by t2 minus t1. And what is the x2 here? 360 minus 0 divided by, and what is the time taken for which the time interval is given, t2 minus t1. They have taken this as interval. So delta t is equal to p2 minus t1. So here you can straight away put 18 because it is given, right? Are you following? Visha?
Yes, sir.
Right. Then, so 360 minus 18, 0 divided by 18 means 360 divided by 18. So how much? 20. 20. What is the unit? Meter per second, right? So this is the average velocity. So you can put V average is equal to, what is that? 20 meter per second. For what? From O to P, according to this first equation, right? Now let us calculate the average speed, okay? So average speed, I'll do it in the next page. Average speed, that is V average. I'm putting capital letter, okay? So in order to distinguish this, right? So the average speed here is, what is the total distance traveled? That is the path length. Am I right? Total distance traveled divided by time interval, the total time taken, interval. So that is equal to, now what is the path length here? O to P is 360 only, right? So 360. And what is the time taken? The time is 18. So here also it is 20, right? So it makes no difference when it is going in the positive direction, okay? So the average speed is this much. So this is the second answer for the first question. Now let us go for the second one, right? O to P and then to Q, okay? Now average velocity. Let us calculate average velocity. What is average velocity? That is the displacement divided by time interval, okay? So here, now listen to me very carefully. The displacement. What is the displacement? Look at here. It is 360, I mean 0 to O to P, right? So from O to P, we have to calculate O to Q only. Okay. Now listen to me carefully. The car is moving here, going here, and comes back, right? So when it comes back, what is the difference between these two? 120. So plus 120 minus 120, that's all. It's cancelled. Like, because you are going forward and reversing from P to Q means you have to subtract 120, right? Be 240 minus 3. So again it can be what? Only 240. Do you understand this? Now let me draw the diagram once again. I am here. Okay. That is, this is 0 and this is the position of O. Now the position of Q, the position of P is here. The position of Q. Now let me draw this. Okay. Listen to me carefully. Here, that is O to P. O to P, I'm traveling. What is a kilometer I travel? 360. 360. I have traveled 360. Okay. So in that case, O, that is this one minus this one. Let me say this is x1, this is x2. Okay. So this is x2 minus x1. That is the displacement, right? X2 minus x1. Okay. And then you are coming back, right? And now this is the x3 position. So here from x3 to x2, what is that? Final minus initial. So x3 minus x2, right? You just follow how I am calculating. Now what is x2? X2 is 360, right? Minus x1 position is 0 plus, what about this one? Tell me. So 240 minus. x2 minus x3, right?
X, yes, X3.
So x2 minus x3.
240 minus 3.
Yes, so x3 position is 240. So x3 is 240 minus x2. What is x2? 360, right? Now 360 minus 0 plus, what about this one? 240 minus 360 means minus 120, right? Okay,
Yes, sir.
follow me carefully. 360, neglect this 0, and plus or minus minus 120, that is equal to 240. I hope now you should be able to understand why I am getting 240.
Yes, sir. Yes.
Okay, right. So let me take 240 here. Okay, so 240 divided by, what about the time? What is the time?
20 minus 2.
No, here, from here up to this one, O to P, it takes 18 minutes, 18 hour or 18 second,
18
and
seconds.
comes back for 6 seconds, right?
So won't we subtract?
Time cannot be negative, no?
So it will be 18 minus 6, which is 12.
No, no, no. You cannot say time is a negative one. Time, it is given as a time interval. Do you understand?
So it's already given as delta.
Yes, this is from here to here, 18 second. That's what given here. Time taken. Okay. What I have given here, T, OP, how much? 18 second. And for return, that is PQ, how much? 6 second. So it is given as interval only, right?
So, but like in the previous, when we
No,
were
that is distance. Position is different from time, na?
so that I got
It is a time interval, ma. There is a difference between time interval and that time. They are not given 10:30 a.m., 10:40 a.m. If it is the case, you can take a 10:40 minus 10:30 like that. But they are simply taken time interval. That's all, right?
the
Right. So V average is equal to 240 divided by 24. So in that case, it is 10
and
meter per second. And since it is a velocity, you have to mention this as plus 10 meter per second. You have to put the value also to be on the safe side. Always for, velocity, you have to mention whether it is positive or negative. So in that case, here also you must put plus 20 meter per second. But for speed, it is not necessary. But for velocity, you have to put. So what is the velocity, average velocity for movement of OP to O to P to Q? Okay. So it is plus 10 meter per second. Do you understand this? Now let us calculate the average speed. The average speed is something different where you have to add. Okay. Take down average speed. Average speed. Right. Now it is equal to, how you can manage here, total path length. Total path length divided by total time. That is time interval here also. When I say total time, which is nothing but time interval in this case, right? So
yes.
here also, what is the total time? PQ, OP plus PQ, right? What is that?
So that's
O to P, QP. Okay. So OP plus PQ divided by T1 plus T2.
eight,
What is OP?
360,
360. What is this one? 120.
120,
Divided by total time T20. So it is 360 plus
20,
120 means how much?
280,
480 divided by 24. So it is 20
20.
meter per second. So this is the average speed. Okay, right? Now you have to report the answer like this. Case 1, that is average velocity, average speed for O to P, and case 2 for the movement of car from O to P and return from P to Q, right? So what is the average velocity, average speed? So what is the first answer? Tell me. I said plus 20, okay?
20.
And what is this?
20 meters per second.
That is also 20 meter per second, right? And what about this?
Plus 10 meters
Plus 10 meter per second. Here,
20 meters per second.
20 meter per second, okay? Are you able to understand this problem? So you
Yes,
have to be
yes.
very careful in understanding the concept. But you can find one thing very interesting. When it is in the positive direction without returning, etc., it makes no sense of difference between speed and velocity. Do you understand this? But when it takes the reverse, that arises the problem. So you have to be very careful. Okay?
Yes, sir.
Right. Now let me go to the next sum. Take down. Let us discuss another sum based on this. A body travels from A to B. Take down at 40 meter per second. From B to A, 60 meter per second. Calculate the average velocity. How to go about? What is the formula to be used here? Average velocity is equal to net displacement divided by time interval. Okay. Now, what are the points given here? They are given only the velocity, but we need time. Okay. And you know about the displacement. What is the displacement here?
Zero.
Very good. So the displacement is 0 because A to B, B to E, right? And what is the two velocities they are given? V1, 40 meter per second. V2, what is that? 60 meter per second. Now T1. How to take T1? S is equal to Vt formula. So T is equal to S by V.
Okay.
Okay, right?
Yes.
So T in that case, now you have to consider this as that is AB. Okay, so here the displacement alone is 0, but not the distance. Do you understand? We do not know the distance. So better you can put AB for S1 and BA for S2. Do you agree with this?
Yes.
So in that case, what is T1? T1 is S by V. That is S1 by V1. What is S1? AB. So you can put AB divided by, what is that? V1. V1 is 40, right? What is T2?
BA by V2, which is
VA
60.
by V2. That is 60. Now what is our formula? VAV is equal to the net displacement. The net displacement means that is nothing but 0. Is it not? Because AB plus BA means it will give the same result. Okay. So 0, and T1, we have got T1 plus T2, let it be. So that is also what? That is already 0. You cannot say 0. You have to say that is a V average is equal to 0 divided by the AB distance. Okay, divided by this 160 plus 1, you can call it AB as a distance, we can keep it. So T1 plus T2 is equal to, let me say, whether it is AB or BA, I'm maintaining this as a distance. So AB, let me take outside the bracket, and 1 by, then this 40. So 1 by 40 plus 1 by 60, right? So T1 plus T2 is equal to AB into, and 60, 40, how much? 24. Is it not? So 1 by 24. So AB by 24, right? So this is nothing but the displacement divided by the total time taken. So VAB is equal to, so the displacement divided by the total time taken is 1 by 24. Okay, 1 by 24. And we do not know what it, this is AB by 24. Sorry, AB by 24. We do not know the distance between AB, but even then the displacement 0. Therefore, AB by 24 means the result is also 0. So likewise, we have to prove. Okay. You should not say AB is 0. AB is not equal to 0. Only the displacement is 0. Do you understand? And that is why I am maintaining this when I calculate the time. Okay. Then let us move to the last part, that is instantaneous speed data. Instantaneous speed. Instantaneous speed means at any moment, at the short interval of time. That is called instantaneous movement or speed here. So the instantaneous speed is represented as SI is equal to, it is given as the a limit of the delta t tends to 0 for delta S divided by delta t. This is also represented as, that is ds by dt. Okay. Now let me explain. For example, see, that is at what time I started this class? 5:10, right?
Right then.
And what is the time now?
6:56.
6:56. So
6:56.
6:56. Okay, so what is the duration? 46 minute, and here 1 hour, right? So I have been taking this class for the past 1 hour 45 minutes, right? 46 minutes, correct?
Yes.
Now that is how much you have learned from me. Tell me.
A lot.
You cannot say a lot. What about Shanvi? How much you have learned from me?
Yes, sir.
Huh? You will say quite a few, only a little. Okay, let us quantify like this. I have covered almost 10, 12 pages, right? Okay, so I have covered 12 pages in how many minutes? 60 plus 46 means 106 minutes, right? So I have covered almost 15, 15 pages. Okay, so let me round off 100 minutes. Okay, and let me say that is 50 pages. So I have covered 15 pages in 100 minutes, right? So you have imbibed, you have learned 15 pages. So if I conduct the test, you will score centum in all these 15 pages, right or wrong. You must. Okay, right. So you are, let us assume you are good girls, you can take. So you take 15 out of 15 for each question. I mean, each page, I ask you, say about 10 marks. It means you can score 150 marks out of 150 marks, right? Let it be. If I teach you, or if you are able to learn from me in 100 minutes, 15 pages, in 1 minute, how many pages you will do?
15 by 100.
How much?
Zero
Point,
one.
0.15 page of content you would have learned from me, correct? Okay.
Yeah.
Now let me reduce the time interval. Okay. Let me reduce the time interval. Say about instead of 1 minute, I am putting 1 second. In 1 second, how much you have learned from me? That is 0.15 divided by 60. Do you understand this?
Yes, sir.
What is the value? Use calculator and get me the value. So in 1 second, how much knowledge is transferred? Shanvi, tell me the answer. I got calculator. Just divide 0.15 divided by 60. Multiply by 10, 100, 0, 0.
0.0025.
So 0025. 0025 amount of learning contents from me, right? In 1 second. Okay. Now, in split second, say about 100th second, how much you would have learned from me? It means that this is a 2.5 into 10 power minus 4 pages. And here you will get 2.5 into 10 power minus 6 pages. Are you able to understand this?
Yes, sir.
So I am going in the very minute interval of time. I am going on splitting the time. You know very well that is, it is very difficult for you to sit for 1 hour 45 minutes. But I am reducing this to 1 second. I am reducing further to 1 by 100 second. I am reducing further to 1 by 10 power n second. It means very, very split second. Okay. So that is the spontaneity. It is the shortest interval of time. What is the changes taking place? Okay. What kind of change is taking place? Are you able to follow this? So what is the displacement taking place in the shortest interval of time? That is called the spontaneous or the instantaneous speed. Do you understand this? Okay. So that is why it indicates the time interval indicates what? It is not zero. It has not reached a zero. Are you able to follow? It means what? I am reducing to the lowest level.
Yes.
So shortest interval of level. For example, that is I started from 510. What is the learning content you have derived in that is 511? It means in 1 second. Can you learn anything in 1 second? You can learn. When I say a word, distance, sir, I learned distance. That's all. Okay. So likewise, when you go on reducing this, and that is called the shortest interval of time, but it is not equal to zero. Instead, you can say delta t tends to zero. Are you able to follow? So such kind of the shortest interval of time is mentioned like this. So this is given as a limit, and that starts the calculus. I'll discuss calculus later. So the instantaneous speed is given here as what? ds by dt, and that is the coefficient. That is, it's called differential coefficient of s with respect to t. Okay, right. Now, in this case, how to calculate such kind of very, distance traveled in split seconds. Okay, take out. If the average speed of a particle, now there is a particle is flying like this. And here, take down the question. The average speed of a particle is, it is given as 2t squared I cap, take down, plus 3t j cap. I'll tell you what do you mean by I cap and j cap. Now listen, this is x-axis, this is y-axis, this is z-axis. Okay, so now the unit vector is called I cap along x-axis. The unit vector along y-axis is called j cap. The unit vector along z-axis is called k cap. Okay. For example, a particle is moving in x direction in order to indicate that, and it's moving almost in x direction 5 meter. So you can call it a phi I. Do you understand this? When I represent like this, it indicates that the particle is moving in x direction because I cap is nothing but the unit vector along x axis. Do you understand this, Prisha?
Yes, sir.
And what about Shanvi?
Yes, sir.
Okay, so let me tell you, you have to mention. Okay, now the particle is moving in uh, y-axis 12 meter. How to represent y-axis?
12J.
Very good, 12j. That's all. Okay. Now a snake is moving in this direction on the plane. It's a planar movement. Okay. How to represent it? It involves both the dimensions. Do you understand this? So it involves I as well as j. When a mosquito is flying like this, it involves all the dimensions, right? So it involves x, y, j. I mean k, z. Got this point? Okay, right. So the average speed of a particle is represented like this. Take down. This is the average speed of a particle given. Find out the instantaneous speed of the particle. So we have to find out the instantaneous speed of the particle. Take down. How to represent the instantaneous speed? SI, right? So SI means what? ds by dt, right? What is that? ds by dt. Okay. So in that case, this is t square. Okay. This is 3t. Now we have to find out. So for differentiation, listen to me carefully. Let me consider x is equal, I mean y is equal to 4x squared, or at least let me start simply. Y is equal to x power n. So find out the differentiation of y with respect to x means dy by dx is equal to, there is a formula, the n should be brought here, nx, and then it should be, 1 should be subtracted from that, n minus 1. This is the formula for differentiation, a simple differentiation. Please note down. Now can you tell me y is equal to say x power 3. What is dy by dx?
3
3 x
3 minus 2.
squared, right? Okay. Now let me give you another sum. Y is equal to 3x cube. Now what is the value of dy by dx? Tell me.
3 x to x square. Can you repeat what's the formula?
Square, right? So what is the value?
So it will be 9x square.
9x squared. Do you understand? Shanvi, got it?
So can you repeat what's the formula again?
So just apply the formula. What is that? Y is equal to x power n. So put the n in the coefficient, then put n minus 1. Okay. Now let me give you another sum. Y is equal to 1 by 4 x power 4. Now what is the value? dy by dx. Now this time Shanvi tell me.
So it will be 1 into 4 x cube.
1 by 4 into 4 into x cube. So 4 cancel, simply x cube. Got it? Okay,
Oh, sorry, I'm a bit confused.
right? Very simple. Y is equal to, formula is y is equal to x power n. So dy by dx means what? The formula, just remember the formula, n into x power n minus 1. That's all. Remember this. Okay. Now let me introduce another formula. Y is equal to a constant and dy by dx is equal to, there is no dx, only constant is there. Okay. So in that case, dc by dx, is it not? So that becomes a 0. A constant, when it is differentiated, it becomes a 0, not on this point. When it is kept alone, right? Now let me give you another sum. Take down y is equal to 3x squared plus 2x minus 4. Now what is dy by dx? Tell me, what is that? You can bring this 3 into 2, 6x, right? Plus 2, then minus 0. Why? Because constant cannot be differentiated, it becomes 0. So the answer is 6x plus 2. Okay, got it? So now what is the problem given here? Let me go to the problem now. What is given? The V average is 2t squared I cap plus 3t j cap. Now it is differentiated between V and the T. Okay, right? So what we are supposed to do? V Si is nothing but, and this is, I mean, they asked for the position. This is, yes, sorry. They asked the VAV. Okay, you can take like this. So S is given here. S is what? S is 2t squared I plus 3tj, right? Now you want to calculate SI. SI is means S ds by dt. So that is equal to, that is nothing but 2t squared. Is it not? Okay. So this is 2t squared means 4t, right? Are you able to understand? 2t squared means what? 4t.
4.
Yeah, 4t into I cap. And what about this? T is 1. So I can put 3j only. Okay. So the answer is instantaneous velocity is 4t I cap plus 3j cap. That's all. Okay.
Yes, sir.
And now let me conclude this session by instantaneous velocity with a better explanation. Take down instantaneous velocity. Instantaneous velocity. So it is given by Vi. So here I was discussing about instantaneous displacement. Okay. Instantaneous speed, not displacement, speed. Now let us discuss about instantaneous velocity. So the instantaneous velocity is given by Vi. Take down Vi, that is equal to limit delta t tends to 0, the shortest interval of delta x divided by delta t. It is also given as Vi is equal to dx divided by dt. Okay, Vx divided by dt. And this dx by dt is called the differential coefficient of x with respect to t. So I'll try to explain this with another example. Take down the displacement in meter of a particle is given by x is equal to 18t plus 15t squared. So this is the displacement along x-axis. Find the velocity, find the instantaneous velocity when t is equal to 0 and when t is equal to 2 seconds. Now listen to me, it's very simple. We know Vi is equal to what? Vi is dx by dt because it is moving along the x direction, right? So what is Vi? Put Vi, differentiate this. So d by dt of 18t plus 5t squared, right? Now what is the differentiation of this one? 18t, 18 plus this one 30t, right? 2 into 15 and t power 1. So Vi is equal to 18 plus 30t. Okay. Now we had to evaluate. That is Vi at t is equal to 0. It means 18 plus 30 into 0. That is 18 meter per second. So this is the first answer. Got it? Now next one. Vi when t is equal to how much? 2 seconds. So 2 seconds. So in that case, 18 plus 30 into 2 seconds. That's all. So 18 plus 60, that is equal to 78 meter per second. Okay. Got this?
Yes. Yes, sir.
Oh, so we have completed 50% of your topic. Or not only 50, I think almost 60. Okay. So in the next class, probably that is I'll be finishing that topic. But you are supposed to work out a lot of worksheets here. I'll send the worksheets. Please try to do that and make this as a very good notes for you and try to complete the worksheet I'm sending you. Okay.
So, one question.
Mm.